I'm going to start off by drawing a box. And we're going to draw a box on a flat surface to represent the box in equilibrium. So I'm going to draw a square or a rectangle, whatever. I'm going to label it. And this box is going to have 4 forces acting upon it because it's in equilibrium. So we'll have a normal force. We'll have a force of gravity. We'll have an applied force. And we'll have a force of friction. So for the box to be in equilibrium, the sum of the forces must be 0. It has to be balanced by an equal and opposite force. So we're going to make our force applied 5 newtons. And then our force of friction, in order to cancel out the force applied, is also going to be 5 newtons. Your force of friction is always negative, though, because it is pulling down on the object. So it'll be a positive 5 and negative 5, which will equal 0. So then we'll have our normal force will be 2 newtons. And our force of gravity will be 2 newtons also, because force of gravity, since it's pulling down on an object, that will equal the opposite of 2 newtons. So this will be a positive 2 newtons, this will be a negative 2 newtons, that will also equal 0. So we have, this is negative, this is negative, this is a positive, this is a positive. So these forces cancel out and these forces cancel out. Therefore, the box is in equilibrium because the sum of all the forces add up to 0. Okay, so instead of having a box resting on a flat surface at equilibrium, now we're going to have a box resting on an inclined plane, and we're going to put that at equilibrium. So we'll draw our box. And now we're going to label our forces. So we have our force, our normal force, which is going to be going up this way from the box. Because if you think about it, if you turn the box this way on a flat surface, your normal force would still be pointing up. So your normal force doesn't point up this way, because now your box is on an incline, so your normal force goes this way. It's still perpendicular to the box. So then, our force of gravity, because gravity always pulls down, we're not going to have gravity pull down on a diagonal. Your force of gravity is going to go this way. So this is our force of gravity. And then we have our force of friction and our force applied. Now, your force of friction is on the opposite side now than it was over here, because now that your box is on an incline, your force of friction is basically what's keeping the box up. Your box is going to slide down this way if the force of friction wasn't pulling on it to hold it up on the ramp. And your force applied is basically the parallel force because it's parallel to the ramp. Now we're going to draw our lines. So you're going to have lines coming. You're going to draw a line. I'm going to draw our lines through here. I'm just going over a few lines. And then you're going to draw another line that is parallel to this line to get your force parallel. Okay. So now we're going to label these new lines that we have. I'm going to label these. So this is going to be this is your force perpendicular, because it is perpendicular to the ramp that the box is resting on. So we'll just label this up here force perpendicular to, so we don't forget that. And then this is your force parallel, because it's parallel to the line with the force of friction and the force applied on it. And then this is your force of gravity, so that's already labeled. Say this angle was 30 degrees. By using geometry, and you could prove that this angle is also 30 degrees. So same goes for any number that you plug into here. This number could be 45, and then this would equal 45. This number could be 15, and this number would equal 15. So on and so forth. So then now we have one angle. This angle is this is a right triangle, basically. This whole thing right here. This whole triangle is a right triangle. So we have our force parallel, our force perpendicular, and now we could use trig to solve for our missing sides. Now, using basic trig functions, you would know that there's such thing called SOHCAHTOA, and I'm just going to write it over here. So SOHCAHTOA basically is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now this is all according to whatever your angle is, so it would be sine of theta, cosine of theta, tan of theta equals opposite over hypotenuse, adjacent over hypotenuse, and tangent equals opposite over adjacent. So using these trig functions now, you can apply it to your triangle in here. So basically, this is your angle, this is your hypotenuse, because I'm going to use a different color. Let's use pink. So because you have your right angle here, this is your hypotenuse, this is your angle, so this is opposite your angle, and this is adjacent to your angle. So now you have all your trig functions ready to be used for figuring out the sides of your triangle. So by using your triangle, you can do it this long way. You could do it the long way to figure out your equations, or you can just memorize the equations. I like to memorize them because they're a lot easier, but using the triangle is a lot more helpful because you're able to visualize what you're doing. But in simpler terms, f of g sine theta equals f parallel, mg sine theta equals f parallel. And then you have f of g sine theta equals f perpendicular, and mg cosine theta equals f perpendicular. So those are your equations that you can use to figure out your sides. So now that we got all the basics down, we're going to try a practice problem. So we're going to draw our inclined plane. And now we're going to draw our block sitting on the inclined plane. We're going to label this, the block is going to be 10 newtons. The block's going to weigh 10 newtons. And the incline of the inclined plane is going to be 30 degrees. Now your force of friction, in this problem, it's going to be given to you, and your force of friction is going to be 3 newtons. So your force of friction for this is 3 newtons because the block is being pulled up the ramp. So your force of friction is going to be over here. If the block was sliding down the ramp, your force of friction would be over here. So we have our block resting on the surface. Now we're just going to draw what we did in this diagram. We're going to draw all of our lines here, and we're going to label all of our forces. So we're going to draw our lines. Well, actually, we'll label our forces first. So we have, let's see. We'll do our normal force in blue. Your normal force. This is your force of friction, so this is your force applied. So we'll just label this your force. Or your force of acceleration, whichever. Or it could be like force F or force X or force B, whatever. And then you're going to have your force of gravity. Your force of gravity we'll do in red. And remember, your force of gravity doesn't go this way. Gravity always pulls straight down. Gravity is perpendicular. Gravity is not perpendicular, it's just straight down. Never mind. Force of gravity. And then now we're going to draw in our lines. So I'm going to take my ruler. I'm going to draw. So this line. And we have this line. Okay. So now we're going to label these lines. Oh, and we forgot another. We have another force parallel. So you're going to draw another line parallel to this green line up here. Okay. So now we can label these lines. So I'm going to label this line. I'll do my force parallel. I'll do my force perpendicular in blue because your force perpendicular is basically the same as the normal force. So this is the force perpendicular. This is the force perpendicular. Now I'm just labeling it in here so that I know from my triangle it's my force perpendicular. And this is your force parallel. So we're going to draw our force parallel. I'll use purple. This is our force parallel. Force parallel. I drew perpendicular there. I can erase that. Force parallel. And this is your force parallel. Okay. Now I'm going to draw my right angle in my triangle. So this is my right angle, and this, because this is 30 degrees, this is also 30 degrees. Okay. Now that I have everything set up, I'll label also my opposite, hypotenuse, and my adjacent. Okay. And we're just going to highlight this triangle so that we remember that we're working with this triangle right here in the diagram. So the question is asking, what is the magnitude of the force applied? I'm just going to call this the applied force for now. So this is, what's the magnitude of F of A? So in order to figure out F of A is parallel to the force parallel. So whatever this force is what F of A is. So we're going to figure that out. So your force of gravity, the equation for force of gravity is F of G equals M times G. So I'm going to write this down. Force of gravity. So in this equation, your force of gravity equals the mass of your object times the gravity of your object. So the gravity is 9.81 and your mass of the object is, so 1 Newton, 10 newtons is equal to 1.0 kilograms. So you'd put 1.0 kilograms because here, this is the equation for this is weight equals acceleration due to gravity times mass. So your weight here is 10 newtons equals your acceleration due to gravity, which is 9.81, times your mass. 10 divided by 9.81 is basically 1. So your mass is equal to 1 kilogram. And you have 10 newtons times equals 1 kilogram times 9.81. I'm sorry, no. You have 1 kilogram times 9.81, which is basically 10 newtons. So your force of gravity is also 10 newtons. So we have 10 newtons over here. I'll write it in I'll circle it in a different color, so I'll circle it in orange. So our force of gravity equals 10 newtons. We'll write all our things over here. Okay. And then now that we have that, we can figure out our force parallel because now we have a side. So our force parallel, I'll do this in purple, equals opposite hypotenuse, so OH. So we'll write SOHCAHTOA over here. So that'll help us out when we do the problem. So we need to find this side. So we need to find, not this side, we need to find the force parallel. So we have to find this side, and we have this side already. So we'll use opposite over hypotenuse. So we have sine of 30 degrees equals our opposite over our hypotenuse, which is 10 newtons. So we have 10 sine 30, so we'll move that over there, equals our force parallel. Now I'm going to go grab my calculator and do that. By plugging 10 sine 30 degrees into my calculator, F parallel equals 5.0 newtons. So I'll write that down here. So now that F parallel equals 5.0 newtons, you will have to add up the force of friction and F parallel, because to pull the block up the ramp at a constant speed, the force must be equal to the parallel component of the object's weight and the force of friction. So you'll have 5.0 newtons over here. But in order to pull the block up at a constant speed, you'll add your 3 newtons. And your force applied equals 8 newtons. So your F parallel equals your 10 sine 30 plus 3 newtons, and there you have your F parallel component. So now that F parallel is 8 newtons, so 8.0 newtons. Now you can find your F perpendicular just by doing SOHCAHTOA again. So you have your A over here, and you can use either one of these sides. We could just go with the 10 because that might be easier. So we could do cosine. So you do, let's do it in, we'll do it in green. So you could do cosine of 30 equals adjacent over hypotenuse. So cosine of 30 equals your A over 10 newtons, and then 10 cosine 30 degrees equals your force perpendicular. And then you put that in the calculator. And 10 cosine 30 is 8.66, so we'll say 8.7. 8.7. So I have another practice problem, and it says a car is at rest on a 15-degree incline. If the mass of the car is 1,000 kilograms, what's the force of friction? So it already says that the car is at rest. And the first thing you want to do with problems is highlight your knowns and unknowns so that you're aware of what you're solving for. So it's at rest. That means the sum of all the forces, the net force, is 0. Because, like I said previously, if an object is at rest, all the forces are at equilibrium, so they equal 0. It also says that the car is on a 15-degree incline. And if the mass of the car is 1,000 kilograms, what's the force of friction? So I'm going to write out my knowns and unknowns. So F net equals 0 because it is at rest. So F net is 0 newtons. Your incline is 15 degrees, so you can draw that on your diagram. Degrees. And then the mass of the car is 1,000 kilograms. Now, we need to know the force of friction because we don't have that. So what we're going to do is we're going to draw our car. For this equation, the car, I'm going to use a block. The car is going to be a block. Now we're going to draw our different forces. So I like to draw my forces in different colors just so that I know what I'm doing. So we have our force of gravity. And remember, force of gravity is always straight down. You don't go diagonally. So this is the force of gravity. Then we have our normal force. Normal force is perpendicular to the surface. And then we have our force of friction, which I will make red. So I'll make this red. And it doesn't say that there's an acceleration or applied force, but I'm just going to put it there anyway so I know in the diagram where it is. And then we're just going to write out some more stuff. So it's 1,000 kilograms. Here, 1,000 kilograms. Now, to figure out the force of gravity equals the mass times the acceleration due to gravity. So, to figure that out, all you gotta do is force of gravity equals 1,000 kilograms times 9.81 meters per second squared, because 9.81 meters per second squared is the acceleration due to gravity, and your force of gravity equals, let's see, 1,000 times 9.81 equals 9,810 newtons. Okay. So now I'm going to draw in the forces. So I'm just going to take a pen and a ruler, and I'm just going to draw my perpendicular forces and my parallel lines. My perpendicular lines and my parallel lines. So we're going to do this. I'm just going to make them a little bit longer. So that's my force perpendicular. This is my force parallel. And then now that you drew out your grid, you're going to draw another parallel line underneath this parallel line to complete your triangle down here. So we're just going to make a parallel line. And now we're going to label our lines. So we have F perpendicular, F parallel, and this is just another F parallel. They're both the same, just one line moved down. Okay, so those are our lines. Alright, so now I'm going to label my right angle in the triangle. This is my right angle here. We're working with this triangle, so I'm going to highlight the triangle just so that it's easier to see. That's the triangle we're working with. And I'm going to label my angle in the triangle. Since this is 15 degrees, this angle here is also 15 degrees, like I said before. And then this side is your force perpendicular side, and this side is your force parallel side. Since the force of gravity was 9,810 newtons, and your force of gravity was this arrow, you can label this arrow 9,810 newtons. So now that you have a side to work with and an angle to work with in your triangle. Now, to find the force perpendicular, which is the force right here, the formula for that is mg cosine theta. So force perpendicular equals mg cosine theta. So your sides for this triangle, the side opposite of your hypotenuse is your h side. So we'll label this side h. And then your side opposite your angle that you're given is the opposite. So it would be O. And then this is your adjacent side because it's the side next to the angle. So your F perpendicular, we already figured out the mass times gravity, which was the weight of the object, which is 9,810 newtons. So you basically just carry this down. F perpendicular equals 9,810 newtons times your cosine of theta, and theta is 15 degrees, so it's cosine of 15 degrees. So your F perpendicular, when you plug that into the calculator, so you do 9,000 810 times cosine of 15 degrees, and you get 9,475.73 newtons. So now that we figured out the force perpendicular, you can label that also so that you have another side to work with. So 9,475 newtons. And for now you can figure out what your force parallel is going to be. So the force parallel is, to find that, you use this equation, which is mg sine theta. So your force parallel equals your mass times gravity, which was the weight. So our mass times gravity was 9,810 newtons times sine, and then theta is 15 degrees, and then we plug that into the calculator. So 9,810 times your sine of 15 equals, parallel equals 2,539.01 newtons. So, if you wanted to label that, that would be your bottom side of the triangle. So you could do a little arrow there and do 2,539.01 newtons. So your force applied, or your force of acceleration over here, becomes your force parallel because it is what's pulling on the object opposite of the force of friction. So this becomes your force parallel over here. So that's 2,539.01 newtons. And then your normal force is equal to the perpendicular force. So our force perpendicular, we said, was 9,475.73 newtons. So your perpendicular force down here becomes negative because it's opposite of your normal force because it's pulling down on the object. Your force of your parallel force over here is negative. So your force of your parallel force over here is negative because it's pulling the object down, and your force of friction is actually positive because it's pulling the object up. It's what's holding the object up, and it is the opposite of your force parallel because, like I said, an object in equilibrium, all of its forces add up to 0. So your force of friction is going to be 2,539.01 newtons. So we have negative 9,475 newtons for a force perpendicular, a positive 9,475 newtons for our normal force, a negative 2,539 newtons for your parallel force, and a positive 2,539 newtons for your force of friction. So the question asks, what is the force of friction? So the force of friction for this equation is going to be 2,539.01 newtons. Okay, so this is the last problem I'm going to be doing because I covered how to find the parallel, perpendicular, normal, force of friction, force of gravity, and that was really what I had trouble with on the test, was being able to figure out how to do this triangle and use trigonometry to figure out my forces. So now that I understand that and have that down, I'm going to be doing just one of the smaller questions that I got wrong on the test that could be helpful. So forces A and B have a resultant R. Force A and resultant R are shown in the diagram below. So we have, I'll draw it out. This is R. And this is A. It's not really that straight, but I tried. And then it says, the question asks, which vector below represents force B? So choice A is this vector. Choice B is this vector. Choice C is this vector, and choice D is this vector. Now, so whenever you're drawing vectors, vectors are always drawn from tip to tail. So since this is your resultants don't always have to be drawn from tip to tail because it's showing the resultant force. The resultants are drawn from start to finish. Okay, so this obviously is where it started, and this is obviously where it's finishing. So if it's finishing here, then the vector B, has to finish over here. So if you have vector A here, vector A goes down, it doesn't finish over there. So this one is wrong. That's not going to work. B shows the vector going up here. If B was this way, the resultant would not be over there, it would be over here. So that's wrong. C shows the resultant. This is drawn from tip to tail, like it says over here. And if you put your C over here, if we insert C into there, it's drawn from tip to tail, it finishes over here, and your resultant is drawn from start to finish, so that could work. C could work. Now D is drawn from right to left. So if you have it from right to left, it goes from tail to tail, and that doesn't work. So this is wrong. So your answer for this question is C. C is drawn from tip to tail, and it ends where the resultant ends from start to finish.